Oh, if under a constant pressure environment, the heat change of our system will be equal to the enthalpy change. And in this section, I will illustrate the grouping of chemical reaction according to the delta H, that is the enthalpy change. Oh, let me draw the free diagram first. And for this diagram is called the enthalpy level diagram. And there will be x and y axis. For the vertical axis, y axis, it will be referred to the enthalpy. And the x axis is the reaction coordinate. It means that when the reaction proceeds, how will the enthalpy of the system change. And last time I introduced the first types of it to you. So for example, when we are burning some charcoal into some carbon dioxide, water, and etc., the product will have a lower energy level than the reactant. And in this case, we can say that okay, the product is relatively more stable. And because the products are more stable, so when the reaction proceeds, it will turn from a high energy level to the lower energy level. Then there will be an energy gap right here. And according to the conservation of energy, energy can neither be created nor destroyed. Then where will this difference in enthalpy goes to, difference in energy goes to? It will goes to the surrounding, and in this case, heat is the format, and then heat will be released to the surrounding. So if you really measure the surrounding environment, the temperature of the surrounding environment, the temperature of surrounding increases, because in this chemical system between the reactant and product, there is a loss in enthalpy. And if you do the simple mathematics, the enthalpy in the product should be with a smaller value by comparing with that in the reactant. The absolute enthalpy in the product will be smaller than that in the reactants. Then what will happen if you calculate really the delta H by subtracting the enthalpy in the product and then minus the enthalpy in the reactant, you will got a negative value of delta H. And for this kind of reaction, we have a special name for it. It is called exothermic. And thermal energy means heat energy, and thermic means there's something related to the heat. And the term exo, the prefix exo, means to the outside. It means that some energy will be lost to the outside, and in Chinese it's called 放熱的. And this is the first group of chemical reaction in terms of the delta H value. If it is negative, then it is exothermic, then it will release its heat to the surrounding when the reaction proceeds. And if you are clever enough, I think you can immediately think of the second and the third types of chemical reaction in terms of the delta H. For the second one, for the reactant and products, they are same in the energy level. And then for the third type, the reactant has a lower energy level than the products. And maybe I introduce the third type of reaction first, in which that the product have a higher enthalpy level. Just like you are holding a ball on the floor and you would like to pick it up. And in the process, when you lift it, of course, you have to apply some energy in the system. And just like in this case, the reactant with a lower energy level, if you want the reactants to react to form the product, of course, you have to apply some energy into the system because the product is now less stable. And you have to apply some energy. It means that heat should be absorbed from the surrounding this time. And then what will happen to the surrounding temperature? It will decreases. Surrounding will be decreased is because some of the heat energy it will be absorbed by the reactants in order to make the reaction possible to become the product. And on the contrary of those exothermic reaction, this time the delta H will be larger than 0. We use another adjective to describe it. It's called endothermic. And endo means that it will absorb energy. Oh, and finally, is the second types of chemical reaction in terms of the delta H. What happens if the reactant have the same enthalpy level as the product, measured under constant pressure? Yes, the delta H will be equal to 0.